For this problem, we are given a 12-foot boom, A and B, that has a fixed end A. It has a steel cable that runs from B to C and is mounted on the wall. It's mounted on a vertical wall. And we're told that the tension in the cable, BC, is equal to 380 pounds. And we're asked to determine the moment about A of the force exerted by the cable at B. And so first thing we'll do is we'll solve for the distance for cable BC. So our distance for cable BC is going to be equal to the square root of the 12 squared. And actually it's a minus 12 squared, isn't it? Not that that makes a difference. Negative 12 squared is going to be 144. But it is from B to A, so it's actually in the negative direction. So minus 12 squared plus, we've got in the y direction, 4.8 height from this point, from A to C, so 4.8 squared plus, we have 8 feet in the z direction from A to C, so plus 8 squared. Okay, and that equals square root of 144 plus 230.4 plus 64 equals square root. All right, so D equals 15.2. Okay, so we have solved for D. And then you'll recall we looked at, and we covered this with sample problem 3.4 in the textbook, that there is a unit vector, lambda, which will equal the vector P BC over TBC, and that our force vector F is equal to that unit vector times F. So we're looking at the vector F equals the unit force, or the magnitude of the force times the unit vector. And we'll look at breaking the unit vector down into the coordinates for the x, or the I, the j, and the k. So now let's say we have, for our magnitude, we have in the I direction, we have minus 12 I, because we're going from B to A in the negative x direction. And then in the y direction, we are going up 4.8, so plus 4.8k. And then in the z direction, minus 8. Oh, that's j. So sorry. 4.8j minus 8k. Okay, so that is our unit vector. And our unit vector times the magnitude of the force over the distance. So the magnitude of our force is 380 pounds. And we solve for the distance of that vector. So we have 15.2. which tells us it's 25. Okay, so knowing that, now we're asked to solve for the moment. And our moment about A is going to be equal to our force that we just solved for, crossed with the position vector. And the position vector of the force, R from B to A, really only has one component, right? So we're looking at the force exerted by the cable at B. At B, we are 12 feet from A in the x direction. So we have M of A equals R crossed our force vector F. And R, B to A equals $12I. And actually, it's minus $12I. Okay, so knowing that now, let's get our moment about A. And let's go ahead and let's do our cross product. So we have I, J, K, 12, 0, 0. And then we have to multiply our 25 times 12. Let's see. It's 300. Okay. 120. And minus 200. So for our vector cross product, M sub A equals, in the I direction, we have 0 times minus 200, 0 minus 0 times 120, that's 0, 0 minus 0 for I. For J, we have 12 times minus 200 minus 0 times 300 J. And for K, we have 12 times 120 minus 0 times 300 for K. So we have 0I minus 2,400 foot-pounds J. And actually, that's plus, because I have minus, and then I have 12 times negative 200. So plus 2,400 foot-pounds in the J direction. And then in the K direction, we have 12 times 120 minus 0. That will give us 1,440 foot-pounds. Okay. So that is our moment in the A direction.